So we've been talking about slopes, and now we're going to talk about the slope of parallel and perpendicular lines. So parallel lines have the same slope. So if we look here at these two lines that we've got on our example graph here, I have one line which has y equals 1/2 x plus 3, and a second line which is y equals 1/2 x minus 1. You'll notice that our slope here, we have a slope of 1/2, and our second line also has a slope of 1/2. So rise of 1 over run of 2, rise of 1 over run of 2. Parallel lines, meaning they will never touch each other. These two lines, since they have the same slope, they are parallel to each other. So we're going to take a look at this diagram here and see if we can figure out if any of these two lines are parallel to each other. And what we're looking for are two slopes that are the same. So we're going to take each line and see what their slopes are, and then see if any of those slopes are the same. So I've labeled these line A, B, and C just to help clarify which lines I'm speaking about. So my first line, I'm going to take my two ordered pairs. I'm going to use the slope formula, and I figured out that we have a slope of 4. My second line, line B, I've used the two ordered pairs. I put them into my slope formula. I figured out we have a slope of 5. And my third set, I have used my slope formula again. I figured out that we have a slope of 4. So I noticed that the first line and the last line both have the same slope, so those two lines are parallel to each other. Remember when we were working with our geometry, we said we never trust the diagram. I don't want to just look at it. I could use rise and run directly from my graph. That would be fine too. But I want to actually figure out some math to describe their slopes before I decide that yes, they are parallel or no, they are not. So the two lines that are parallel are lines A and line C. Perpendicular slopes, and we know that two lines are perpendicular if they form a right angle. Perpendicular slopes have opposite reciprocal slopes. So what does that mean? Opposite reciprocal, opposite, meaning I'm going to take the two and they should be opposite signs. So one is a positive and one is a negative. Reciprocal, I look at it as a fraction and I flip it. So here I have these two lines on my example graph, and they are perpendicular to each other. You notice that this line that has a positive slope has a slope of 1/2, and the second line has a slope of -2/1. So notice 1/2, its reciprocal is 2/1, and they're opposites. One is positive and one is a negative. So I'm going to recognize perpendicular lines by noticing that they have opposite reciprocal slopes. So let's take a look at this diagram and see if any of these lines are perpendicular. Now if they're going to be perpendicular, they're going to be perpendicular to F. So we're going to pay attention to the slope of line F. So line F has a slope of 7/2. Line D and E, when I figure those out, again I use the slope formula, and I figure out that line D has a slope of -1/3. That makes sense because it should be a negative line, but that is not opposite reciprocals. They're opposite, but they're not reciprocals. So now I'm going to figure out the slope of line line E. Again, slope formula, ordered pair, ordered pair. I come up with a slope of -2/7. So notice these two slopes, they are opposite. One's negative, one's positive. And they are reciprocal. I have 2/7. If I flip that, I get 7/2. So lines E and F are perpendicular because they have perpendicular slopes. One has a slope of -2/7. The other has a slope of 7/2. So our perpendicular lines, again perpendicular meaning they form a right angle, a 90-degree angle in there. They need to have opposite reciprocal slopes.